and I'd like to begin today by painting you a picture. This picture is of a massive table, and on that table you have enough food to feed billions of people. Tragically though, this unique table loses 1/5 of that food before every single meal. The food is lost, blown over, destroyed, never to meet the mouths of the people it was intended to feed. This analogy represents a real-life scenario. The food on the table is 3 critical crops, and that limiting loss is the problem of stock lodging. Stock lodging, or the breakage of plant stems prior to harvest, affects corn, wheat, and rice most heavily. These crops represent 2/3 of the world's caloric intake, and we lose between 5 and 25% of them every single year. The damages are heavy, and if we reduce these lodgings by 1% for corn alone, we would produce another $2 billion of this crop every year. With such high losses, it's no surprise that agronomists and biologists have been working on a solution for almost a decade. The past methods, though, have strictly measured late-season lodging counts in order to identify which genomes are most effective at resisting lodging. This solution, though, is a band-aid approach and doesn't actually analyze the problem. It looks at stock lodging as a black box and doesn't actually consider the biological process that is occurring or the traits necessary to prevent it. At the AgMEQ lab, we're looking on a different solution. Our goal is to create a model that can accurately predict the phenotypes or predictive characteristics of any given genotype and the environment constraints and identify what traits this is going to produce. In order to do this, we're building a model that contains data from thousands of different stocks of hundreds of different genotypes. That data will be used to create a model that can accurately predict which genetics are going to produce the stocks that are most resistant to lodging. In addition to this work, we're also developing testing equipment in-house. So far, we've developed a bending device, a compression measurement device, and a rind puncture resistance measure device. These devices are all relevant because they allow us to identify and gather the data that is relevant to stock lodging. After working in the lab for a couple semesters, I'm looking to travel to our collaborative locations for a weeks-long trip to get more experience working with agronomists using our devices in the field. I have the funding split up right here, and that's for airfare, per diem, salary support, and transportation while I'm there for that week. This is relevant to our project because it helps us design our devices better to work in the field, and it'll allow me as a researcher to better understand the problem I'm dealing with because I've seen it firsthand. That's all I have for today. If you have any other questions, I'd be happy to answer them. Thank you.